Welcome back. Now let me just review what we saw in the first video today. Three different ways you can express the law of exponential to growth. They're all really important and you need to be familiar with all of them. The first one is just the verbal expression of the model, and that is basically the verbal description of the differential equation. If the rate of change of a variable y, now again, you could use another variable for this like p because we often use it for population, but if the rate of change of the quantity y is proportional to y, and y is a function of time, then you get this derivative dy dt, and the proportional part means dy dt equals ky. So this already shows you two of the things, the verbal model and then the derivative, the differential equation that is a direct translation of the verbal model above it. Now what we did in the last video was use a little bit of integration, and seeing this as a separable differential equation, we were able to derive this explicit equation for y. Y equals the constant a times e to the kt. And we saw that k was called the relative growth rate, and a, the quantity a, can be seen to mean the starting of value of the population, because if you see here, if I go and let the time be 0 and e to the 0 just becomes 1, we get a is y, right? So a is the starting amount, y of 0. So if you're given the starting population, you already know what the constant a in this model is going to be, and then you might still have to solve for k and figure out what it is. Now, I would strongly encourage you, if you would grab your graphing calculator, you will use it in solving the problems today. So if you don't have it sitting there with you, I would encourage you to grab it at this point before we go to the examples. So we're actually going to start in each problem by giving you a verbal description of the problem, but they all will be that verbal description of the law of exponential growth, and that is the rate of change of y is proportional to y. So you're expected to know that this is the translation, dy dt equals ky. Now you're also expected to just know, you don't have to do the integration of this every single time. You're expected to just know and allowed to just know that it now becomes the law of exponential growth and decay, and this is the equation. Y equals a e to the kt. Now the question we're ultimately wanting to find, it says find the value of y at the time t equals 3. Now we won't be able to do that until we have the complete model determined, and right now we don't have the quantity a or the quantity k filled in yet. So that's why, because there's two missing constants, there has to be two given pieces of information, and those are right there. So if you think about it, the graph of y equals a e to the kt, hopefully you're a little bit familiar with, the graph of y equals e to the x, which this is just a different version of that. It'll be scaled a little bit differently because of the quantity a and the quantity k, but essentially, if the quantity is growing, which this one is, when t equals 0, the y was 2, and when t equals 2, the y was 4. So essentially, you're given 2 points, the point 0, 2, and the point 2, 4, right? And you're also supposed to know that because of the fact that we're following this model right here, it's not going to be a line, it's going to be more like this. Okay, it's going to be this exponential curve. And we have 2 points on it right now. We've got the point 0, 2, point 2, 4. So we're supposed to use those to figure out the entire equation, and then use it quite easily at the end to figure out what the y value is when t equals 3. So one moment of time later than this. Okay. Now, one big clue, remember, that we learned in the first video was, if you're given the quantity of y at the very beginning, that's very useful, because if I go right away and plug in a 0 for t, it's going to get rid of all of this e to the kt, and you'll just be left with a on this side. So right away, when y is 2, the equation becomes 2 equals a times e to the 0, and see right away you know that a is 2. So we're part of the way down. Now we know so far that y is always going to be 2 e to the kt. Okay, now the next time you see a problem like this, if you see the ordered pair 0, 2, or 0, 5, or whatever, you could just right away know that that number there is the A. And now the second clue is going to help you now find the relative growth rate, the K, right? So now I will take my ordered pair now and replace the Y with 4 this time. We already know the A is a 2, and this time the time is 2 also, but I don't know the K. Right? So I filled in, this is like y equals a e to the kt. And we know the capital A is 2, and in the second ordered pair, the time is 2, and the y is 4. So the part we need to do is solve for the k, right? I can divide both sides by this 2. So 2 equals e to the, I'm going to write it like this now, e to the 2k. And hopefully you guys are familiar with how we're going to solve it from here. I would encourage you even just to think about that on your own for a minute, how we're going to solve for the k. The first step, of course, will be to take the natural log of both sides. So on the left, it ends up with the natural log of 2. And over here, the log and the power, the base e, cancel. So you're just down to 2k. So you can conclude the value of k is the natural log of 2 all divided by 2. Now, I can go ahead and now write my final model, y equals 2 e to the power of, now it gets a little bit cumbersome to write it all down, but it's the natural log of 2 over 2 times t. So this expresses y as a function of time. Quite often on an AP test, that's what they really want you to do, was do all this work to come up with what is the function for y. And now you have it, okay? Now, what will make this easy to carry out in the next step on your calculator actually is to do this. I encourage you now to take your calculator. I've got mine right here, and we're gonna save the number k as the natural log of 2 divided by 2. So I'm gonna first type it in, the natural log of 2, all divided by 2. And so now there it is in decimal form. And I want you to use the store button. And notice that the letter K is right above the left parenthesis. So alpha K, and we'll store that quantity as K now. So for example, anytime you want to type in K from now on, it'll be that number. Okay. Now, back to our situation here. What we want to eventually do is find y when t equals 3. Now this is very easy because I know the entire function for y. All I've got to do is 2e to the, now I'm just going to write it as k again, k times the time 3, and literally this is all you have to do to type in your calculator because you've already got the k stored, right? So watch what we're going to do. It'll just be 2e to the power of 3, and then alpha k. There's no need to type all that messy stuff in again. And we get our answer, and we'll round to 3 decimal places. So this will be 5.657. And we could call that y of 3. Okay? So this one here is similar. The main difference is we're not actually told the starting value of the population this time. So, but it is the same situation. The rate of change of y is proportional to y. And that immediately leads us to knowing this is going to be the equation of exponential growth and decay. Y equals a e to the kt. The main difference here is you don't know, you can't right away tell what a is because we don't have the starting value of our population. We have the amount when t equals 1, and we have the amount when t equals 3. And what we ultimately want is what the value is when t equals 5. Okay? So this time what we're going to do is we're going to one at a time. Actually, I'm just going to call this equation number 1 and use the first ordered pair. So in the first ordered pair, the y value is 2 and the t value is 1, or just be y equals 2 equals a e to the k. Now, equation number 2 will be from the second ordered pair, and the y value is 7 when the t value is 3. So it'll be e to the k times 3. Now, both of those still have the two missing constants. So what is necessary this time is to somehow combine them. So what I like to do is take one of them and solve for the capital A and then substitute into the other one. So let's take the first one again. And if I take A equals, and I divide it by e to the k, it would read A equals 2 over e to the k. And we can now bring that and substitute into the other one, right? So we're going to go like this. 7 equals, and now I'm going to bring 2 over e to the k times e to the 3k. And my goal is to now somehow solve this for k. Now look at your algebra here. This is e to the k over 1. So I'm going to be able to divide these, and note that we subtract the exponents here. So 7 is 2. And then by taking e to the 3k divided by e to the k, that should be e to the 2k. Because notice we subtracted the exponents when we're dividing. That's some algebra there. And now we'll just solve for k. We can do that by dividing by 2 and then taking the logs again. So 7 divided by 2 is 3.5. And I'll take the natural log of 3.5 equals 2k. We're taking the natural log of both sides. And so now we're going to take this and divide by 2. So notice your k value is the natural log of 3.5 divided by 2. I want you to right now to go grab your calculator, and we're going to resave the k value. So I'm going to take the natural log of 3.5 divide by 2, and we're going to store that as letter k again. We'll just override the previous one. So there's our value. Okay. And now we're going to solve for the quantity a by noticing that, remember back in our first equation when I rewrote it, a was equal to 2 over e to the k. So I'm now going to be able to solve for a. And I'm going to do that on my calculator also. Okay. So I'm going to take 2 divided by second e to the, and I'm going to use that stored value of k. So there it is. And I'm going to save that now as the letter A. Okay. So now I've got both the constants A and K are stored in my calculator. And now I've got to find the y value when t equals 5. Okay, so I really want to find y equals A times e to the 5k. And I'm literally going to type that into my calculator because I have the a value stored and the k value stored. Okay, so I'm going to take this and go a times e to the 5k. And I'm going to get 24.5 exactly. Okay, so this would be considered y of 5. It's the y value when the t equals 5. Okay. final answer. So you saw two examples today. One was a little bit simpler because the initial value of the population was given. That leads directly to finding the constant A in the model. The second second example here didn't have that, so there's a little bit more work to figure out both of the constants before you could finally evaluate the function. I hope this helps you guys. Keep me in the loop if you need any help, and I'll look forward to hearing from you. Thanks.